Welcome to our cam and crank position sensors video. In this video, me and Drew are going to go over cam and crank position sensors, what they do, looking at testing the internal resistance, checking voltages on multiple different kinds of sensors, as well as just showing a better view of how the sensors work. We're going to look at the cam and crank sensors on two different vehicles in this video.
Today we are working on a 2006 Toyota Corolla. Here we have the wiring diagram for our crankshaft position sensor and also our camshaft position sensor. The black wire is going to be our power and the white is going to be our ground. Seeing as this is a two-wire system, this is going to be analog and it's going to be a variable reluctance system.
So this is the testing page on all data for our camshaft position sensor. As you can see, our cold sensor should have 835 to 1400 ohms. Alrighty, so now we've got our ohm meter connected to the positive and negative terminals of our camshaft position sensor. And as you can see, it's reading about 1.1 thousand ohms, which is right in spec of where we want it to be.
Alright, yeah, now AC we're getting 1.35.
So here we are back probed onto our camshaft position sensor. You can see we're on the power wire and our ground lead is on the negative terminal of the battery. Here looking at our picoscope readings, you can see as the engine is running, you can see the three spikes implying like those are the gaps in the reluctor wheel. And you can see this gap in our voltage reading where the reluctor wheel gap is not there, or something has changed in the reluctor wheel so that it knows the position of the camshaft.
So right now we are currently idling and this is our voltage. We have our certain gaps due to the reluctor wheel, and we're just going to see as we increase RPM, will we notice any change in the gaps. Alrighty, so just looking, as we increased our engine RPM, our voltage did go up and our gaps became a little bit shorter, and that's only because we started hitting them faster.
Alright, so here I am unplugging this camshaft position sensor, and I'm going to try and start the vehicle and see what it does. Now we're going to look at the Chevy Cobalt stand engine, where we have a better view of what the actual crank position sensor is doing and how it works. So here's the wiring diagram for our Cobalt stand engine, and as you can see here, here's our crankshaft position sensor. It's a 3-wire sensor. It's got a power, a ground, and a signal wire.
Alrighty, today we're going to be working on our Cobalt engine stand. We're looking at our crankshaft position sensor. Today we're going to be looking at our Cobalt, the reluctor wheel. We see it has one huge gap, and then the rest of the gaps are going to be momentarily, like noticeably smaller and closer together. We're going to walk over to our keyboard. Right now, with the engine off and nothing running, we are sitting at, I want to say, 0 volts. And then as we cut this on, you can see our gaps. We have that one big gap, and it's going to spike to 5 volts and then back down.
Alright, so here we are again looking at this crank sensor on this Cobalt engine stand. And the interesting thing that we wanted to show you guys is the way this is set up. You can actually move this crank position sensor, and as you move it away from where these teeth are, you can actually see everything stops working, and even our signal on our picoscope dies. Which really just shows, like, it helps you realize, put into perspective, the actual reading of those teeth, and if it's not directly in front of those teeth, then our engine doesn't know what speed the crankshaft's running at, it doesn't know where the cylinders are, and therefore it shuts down. Thank you for watching our video. I hope that after watching this video, you have a better understanding of cam and crank position sensors. We hope that you understand how they work, how to diagnose them, and what you should be looking for when you have an issue related to a cam or crank sensor.